guys, and welcome to lesson 2.5, the shortest lesson of the semester. So all we're going to do today is kind of review that factoring flowchart that I showed you in the last unit. So remember, the first thing that you do when you're factoring is you always check for a common factor. And then when you've done so, you want to count the number of terms. Remember, when there are two terms, we already discussed this, that something that we can do is the difference of squares. When there are three terms, we can check to see if it's a simple trinomial, a complex trinomial, or a perfect square trinomial. And finally, if there are four or more terms, we always did factor by grouping. But recently, we've done a little bit more factoring, a little bit more complex factoring, so we're going to add to this chart. Now, when there are two terms, yes, you can do difference of squares, but you can also consider the sum or difference of cubes. When you have a polynomial of four or more terms, you might want to consider factor by grouping. This is something that I want you to check first. Sometimes it will save you a lot of time on a test. We're going to do some examples of this on the next page. And remember, you don't always have to do two groups of two. Let's say if you had a polynomial of four terms. Sometimes a group of three and a group of one would work. And then finally, if you have a degree 3 or anything higher, you can try the factor theorem. So that should probably be your last resort, because you want to check quickly to see if you can do any of these other methods, because they are all much shorter than doing factor theorem. So we'll go ahead and do those two examples really quickly. First example, we have x squared minus 6 plus 9 minus 25y squared. So right away I see that I have two variables, and if I grouped this group of 3 and then left the 25y squared alone, I can see that the first group ends up being a perfect square. We're left with two terms that are three perfect squares, x minus 3, and the minus will give me that expression. So we're going to do difference of squares. Minus 25, the first term gives us x minus 3, square root the second term, and then exactly the same thing in the second bracket, except for a minus 5y. And there we go, fully factored. For example B, we have 6 terms. Again, we see that x squared minus 6 plus 9, so that's probably going to be in its own group. And the last three terms definitely look like a perfect square trinomial. But remember, a perfect square trinomials, the last term always must be positive. So what we're going to do is we're going to factor out a negative out of this last group. So we have x squared minus 6x plus 9, and then we take out the negative, and we're left with positive y squared, negative 10yz, and then positive 25z squared. So our groups are clearly defined now. There's the first group and there's the second group. Both end up being perfect square trinomials. So x minus 3 squared for the first one, and y minus, and then square root the last term here, so y minus 5z for the second group. And then again we have difference of squares. So we have x minus 3, so that's the square root of the first term, take away the square root of the second term. Now brackets here are so important because we need to distribute that negative here, and we would forget to do so unless we had these little round brackets. In any case, second bracket gets the x minus 3 and then plus y minus 5z. And then we just expand and simplify. So there's a positive 1 in front of this bracket and a negative 1 in front of this bracket. And again, positive 1s in front of both brackets. And if you had any like terms, you would collect and simplify. But we don't, so we are all done factoring. So that's it for today. I mostly just wanted you to focus on this chart right here, and I will see you guys in class. Take care.